All right, volume homework number 1. So by now you guys have watched day 1 and day 2 videos. You should be good to go with 7.3. So what we're going to do now is pull a couple of problems from the worksheet. It's a little bit area, a little bit of volume, so I figured let's do one of each. So let's do number 2, and it says find a horizontal line y equals k that divides the area between y equals x squared and y equals 9 into 2 equal parts. All right, well let's draw a picture and see what we're working with here. Okay, so we have a parabola y equals x squared, and so we have y equals 9, which is up at the top. It's right here, y equals 9. And we're going to split this thing into two regions. We're not quite sure where, but we know that the value is going to be k. Okay, and the goal is that we're trying to make the area of this right here, region 1, all that region, and we want that to just be equal to the area of all this stuff here in region 2. All right, so let's just get rid of that so we can put some rectangles in there. The question is, should we use a horizontal or a vertical rectangle? Now, even though our function is in terms of x, a horizontal is going to be best here. And the reason is because if I draw myself a horizontal rectangle right here in this region, and also another one right here in this region, you can see that there's always a right and there's always a left. All right, and they're defined by the branches of the parabola. Okay, so if we need to use a horizontal rectangle, we need to switch this thing into x equals plus or minus root y, with this one being negative root y and this one being positive root y. Okay, so I think we're ready. Let's put this back here. Let's call this region 1 and we'll call this region 2. Okay, so region 1, the area of region 1 is going to be the integral from the y value, well the smallest y value is 0, and the y value that we're going to stop at is this y value right here, which we're calling k. All right, and it's going to be the right function minus the left function, dy. So it's radical y minus negative radical y dy. Okay, and then the second region, region 2, is going to be pretty similar actually. It's going to be the integral. This time we're starting from k. We're going to 9. Okay, so we're going to start at k and go to 9. And it's still going to be right branch of the parabola, root y, minus left branch of the parabola, negative root y. And the goal is to set these things equal to each other and solve for k. All right, so let's see. Let's clean them up. This is going to be the integral from 0 to k of 2 root y dy. And this is going to be the integral from k to 9 of 2 root y dy. And what I would do is pull the 2 out of the integral right now, so you don't even have to worry about it, okay? So it would just be root y dy. And this is 2 integral k to 9 root y dy. Okay? And the 2's out in front, that's totally fine. So here's what's going to happen. First of all, I'm going to cancel the 2's, because essentially I just divide by 2 on each side and the 2's are gone, okay? So I'm going to take the antiderivative of y to the 1/2 power, which is 2/3, y to the 3/2, and I'm evaluating this thing from 0 to k. And I set this equal to the integral 2/3, y to the 3/2, and evaluating this one from k to 9. Okay? So if I were to actually use the fundamental theorem of calculus here, this is what it would look like. It would be 2/3 k to the 3/2 minus 0, right? Because 0 plugged in that function for y is just 0. And on this side it would be 2/3 times 9 to the 3/2, and then let's just do the minus 2/3, and this is k to the 3/2. So this is the fundamental theorem of calculus with both of these things, okay? So if you think about it, the 0 is gone, and I've got a negative 2/3 k to the 3/2 and a positive 2/3 k to the 3/2. I'm just going to add over this negative 2/3 k to the 3/2. I'm going to add it over. And what that's going to be is just simply 4/3 k to the 3/2. 2/3 plus 2/3 is 4/3 k to the 3/2. And I can actually solve this out. Square root of 9 is 3, cubed is 27. Divide 3 is 9, times 2 is 18. All right, so that'd just be 18. And then I solve. So to get rid of the 4/3, I'm going to multiply both sides by 3/4. I'm going to get k to the 3/2 is equal to 13.5. And then if I, to get rid of the 3/2 power, I'm going to raise everything to the 2/3 power. And so that's just going to be k equals, and I'm going to get 5.670, which is the value of the horizontal line such that the regions will have equal areas. All right, so that's an area problem, horizontal rectangles, pretty good stuff. Okay, let's try this one. This is number 3, and it's a volume problem. And we're going to revolve these things around the x-axis, the y-axis, and the line y equals 3. So I think let's do y equals 3, because we haven't really done anything like that in the videos. We normally worked with the x and the y-axis for solids of revolution. So let's try part C, okay? Let's see if we can sketch ourselves just a rough picture here. Let's see what we've got. So we've got the line y equals 0 right here. Y equals 0 is nice. It's just the x-axis. This whole axis here, y equals 0, so that's good. X equals 9 is a vertical line. I'm going to throw it right over here. We'll just do x equals 9 right there. Okay, and then everything else is just the square root. So we'll put the square root right in there, and there's rad x. And so I'm going to revolve this thing around the line. It looks like y equals 3. So I'm going to put that in there. So y equals 3. And I actually drew a pretty good picture because right here, this is 3 squared is 9, so root 9. So it actually fit quite nicely. I can put the line like right here, I'd say. Put the line like y equals 3 in here. Okay, so y equals 3. So square root of 9 is 3, so that's why this intersection point's good. And then I'm just going to reflect it. So it's going to look a little like this. We use a dashed line. So we're going to start off like this and kind of go like that. Okay, so this is the area, or rather the volume of the region I'm trying to find when revolving it around y equals 3. So let's think about this. Disk or washer? Well, I have a lot of area right here that's not going to be reflected. There's basically empty space. So it's got to be a washer in this problem. Okay, so I'm going to use a washer. Let's go ahead and, actually I should probably slice it first. Horizontal axis of rotation, vertical slice. Dot right here for the axis of rotation. I go until I hit the curve, right? I don't use the reflected image, right? Go until I hit the curve, and then go all the way down until I hit the end of the problem. So this is going to be my little r, and then this right here is all going to be my big R right here. Okay? Let's draw a picture. So I've got a washer, thickness, all right, and I've got, this isn't too bad. The whole from, not the whole, but the entire distance right here is 3. So if I think about what's the value of little r, it's 3 minus the value of f of x, or 3 minus square root x. So little r is 3 minus square root x, okay? So we got right here little r and big R. Big R is really easy, it's just 3. We just said that. Big R is the distance from y equals 3 to y equals 0. So it's just 3. So I think we're ready. All you got to do is set it up, and this is area equals pi times the radii squared. So this is pi times big R squared is 9 minus, and this is 3 minus square root x squared. Okay, and then we integrate. And be very careful with your bounds. It should be 0 to 9 because we're using y values. So volume equals the integral, and we'll pull the pi out. And it's going to be 0 to 9, and it's going to be 9 minus 3 minus root x quantity squared dx. And if you plug that into a calculator, it is going to give you volume equals 212.06, or if you want it exact, it's 67.5 pi. Alright, so either one of those would be appropriate. So try the rest of the worksheet out. I'm going to put the answer key on X2, so kind of check your work as you go, and just make sure for the problems that only ask you to set up, just set up. You don't actually have to find the answers. Alright, so give those a shot. Tonight, start the bookwork, try it out, use the class period tomorrow, work together on things you didn't understand, and then obviously over vacay you guys have the practice AP exam. Alright, good luck. I hope you enjoyed the 7.3 flips.